We come across many objects in our daily lives that have length, breadth, and height or depth. Take a look at the Earth, for instance. It resembles a sphere. While packing for a trip, have you ever noticed the shape of a suitcase or a trunk? That too has 3 dimensions. Similarly, the pyramids of Egypt, a waffle cone, a lawn roller, a football, to name a few, are all examples of 3-dimensional solid shapes. Welcome to the lesson on Introduction to Solid Shapes. At the end of this lesson, you will be able to count the number of faces, edges, and vertices of solid shapes. You will also be able to identify the nets of different solid shapes and draw isometric and oblique sketches of solid shapes. Look at this sheet of wrapping paper. Can we say it has length, breadth, and height? Not really. Paper has only length and breadth, and hence is classified as a plane or 2-dimensional figure. All 2-dimensional figures have only length and breadth. Now, take a look at this biscuit tin. Can we say it has length, breadth, and height? Yes, it does. 3-dimensional solid shapes have length, breadth, and height. Many solids that we see in our day-to-day life have 3 distinct parts, namely faces, edges, and vertices. Take a look at the 3-dimensional solids given here. The flat surfaces that form the skin of the solids are called its faces. The line segments that form the skeleton of the solids are called edges. In other words, 2 faces meet at a line segment called the edge. Finally, vertices are the points where 3 edges meet. Now, look at the square pyramid given here. How many faces, edges, and vertices do you think the pyramid has? We can see that it has 5 faces, 8 edges, and 5 vertices. Similarly, we can count the faces, edges, and vertices of other 3-dimensional figures. Did you notice that the 3-dimensional pyramid is actually made of 2-dimensional faces? The pyramid here has 4 triangular faces and a square base, which are all 2-dimensional figures. Let us now discuss another way of visualizing a solid object. A 3-dimensional shape can be visualized in a 2-dimensional form by creating nets. The net of a 3-dimensional solid is a 2-dimensional skeleton outline, which when folded results in the 3-dimensional shape.
The view from here is beautiful.
Absolutely.
Look at the museum. Isn't the entrance looking majestic? All I can see from my house is the rear end of the museum.
Just look at those houses. They appear like little matchboxes, and the trees look like little bushes.
Welcome to the lesson on viewing different sections of a solid. At the end of this lesson, you will be able to recognize the different views of a solid and identify the shape of a cross-section of a solid when cut vertically or horizontally. You will also be able to identify the shape of a shadow cast by a solid. Look at the objects shown here. You can see that each of these have length, breadth, and height or depth, and so are called 3-dimensional shapes. Did you know that 3-dimensional objects can look differently from different positions? Take a look at the bus given here. you can look at this bus from different angles, and from each angle, it will look different. If you look at the bus from the front, you can see the front portion of the bus, which includes the windshield, the mirror, and the headlights. This is called the front view of the bus. Now, look at the bus from the side. What do you see? You will be able to see the windows, the door, and a part of the bus's body. This view is called the side view. Now again, look at the bus from the top. This time, you will be able to see the top portion of the bus, which is a simple rectangle. The front, the side, and the top views are the three most common views of a solid object. Besides these three views, you can see other views too. The view depends on the location from where you're looking at the object. You must have also noticed that when you observe a solid from a particular angle, certain views of the solid get hidden. This was the reason why Ruby wasn't able to see the entrance to the museum from her house.
Our trip up the hillock was a lot of fun. I never knew objects could look so different from a height.
We must plan another trip soon. Ruby, I'm feeling hungry. Is there anything to eat?
Mummy had bought some cake yesterday. Let me cut a slice for you.
Cutting or slicing is another way of viewing a section of a solid. Did you notice the cake before it was sliced? It was in the shape of a cuboid. Once the cake was cut vertically, there were several pieces of the cake, each having a rectangular face. This rectangular face is called the cross-section. Also, if you notice, the boundary of this cross-section is a plane curve. But this is not the only way in which a cake can be sliced. Let's take another cake and cut it horizontally this time. What do you see? You can see that the horizontal cross-section is longer than the vertical cross-section, and though both cross-sections are rectangular, their sizes differ. Thus, solids can be cut either horizontally or vertically to obtain their cross-sections. But remember one thing, care must be taken while cutting a solid to ensure that the cross-sections are uniform.
Oh no, there goes the electricity.
Wait a minute, I'll light a candle.
Hey Ruby, look at your shadow. It appears so much longer than you actually are.
Take a look at your shadow.
If you look at Ruby's and Lisa's shadows, you can see that it has no depth, just length and breadth. This is true for any shadow. Shadows are two-dimensional representations of three-dimensional solids. Now, observe the shadow of a person at different times during the day. You can see that the length of the shadow changes with the change in the position of the sun or the light. This was the reason why Ruby's and Lisa's shadows were looking much longer than their actual height. Congratulations! You have successfully completed this lesson. In this lesson, you have learned to recognize the different views of a solid, identify the shape of a cross-section of a solid when cut vertically or horizontally, and identify the shape of a shadow cast by a solid.
Question number first. What cross-sections do you get when you give a vertical cut and horizontal cut to the following solids: a brick, a round apple, a die, a circular pipe, and an ice cream cone. In this question, we are required to perform two cuts, that is vertical cut and horizontal cut. And both cuts are very simple. They are very much known to you. So let's start answering. Number first, a brick. This can be an ice cream brick. So that is your brick. First of all, let's perform vertical cut on it. Vertical means you are taking your knife and you are cutting it perpendicularly. This brick will be divided into two sections, and one of the section will look like this. And now what is a cross section? So cross section is this newly generated face that we get after cutting it vertically. So the question is asking that of what shape cross section we get after performing a vertical cut on a brick. So as you can see, it is a rectangle. So that is first cut. Now we will take the same brick and we will cut horizontally. That is, we will cut from here to all the way around. Then you will get cross section like this. Again, it will be a rectangle. Therefore, we will get both rectangles cut. The only difference is that in horizontal cut, the area of this cross section will be bigger. That is, here we will have length and depth or breadth. Here we will have depth and height. If we were required to find out its cross sections area. So this is all about cross sections, and let's see for other items as well. A round apple. Here you can see a green fresh apple. You must eat it every day because an apple a day keeps doctor away, as the saying goes. So it's a round apple. So when you perform a horizontal cut, that is, you will cut like this with the help of knife or with the help of your imagination, you will get a circle. So this is a circle. So the cross section that we get after cutting an apple horizontally, so we get a circle. That is horizontal cut. When you make a vertical cut, that is, whenever you are cutting your apple, you make a cut like this, then you again get a circular cross section. So in both ways, you get a circular cross section. So what we learn from these both vertical cut and horizontal cut? We learn that a solid is composed of similar looking cross sections. When they are repeated multiple times, then any particular solid is attained. For instance, if this rectangle is piled up, then you get a brick. Again, if this circle is piled up, you get an apple. So this is mathematical way of describing solid items. Now for a die, obviously you know a die. Well, it is an isometric view. As you can see, we have shown this dice in angle. Therefore, it is an isometric view. We will cut this die horizontally with our imagination. Then upper part, we are not showing it. We are just showing the bottom part that we are left with. So it will be a square again, because a cube is made up of square ultimately. Again, when you perform a vertical cut, now we will cut like this in our imagination only. Then we will get again a square as the shape of cross section. So this is vertical cut, this is horizontal cut for a die. Then a circular pipe. Well, you have seen circular pipes carrying water to your house. So this is your circular pipe. When you make a vertical cut, then you will get again a pipe, but smaller in length. So this is vertical cut. Again, this cut is in circular shape. That is, this cross section is of circular shape. But when you cut it horizontally, then you get this image. Therefore, what is this? This is a semicircle. That is the cross section we attain after cutting circular pipe horizontally. We get a semicircular cross section. So that is for circular pipe. Now for an ice cream cone. This is your cone not containing ice cream. We are tilting it due to space issues. So when we make a horizontal cut, let's first make a horizontal cut on it. Then again it will be like this. Then this portion will be left, and this cross section is again semicircle. Again, when you make a vertical cut, that is, we are cutting from here like this, then we get this. The cross section that we get is a smaller circle. That is, we get a circumference of the circle. So it is a vertical cut. So this is a basic idea about cuts, that is vertical cut and horizontal cut. You cannot always take a knife and perform these cuts. The point is, you must develop such an imagination that you can imagine whatever cuts the questions asks for. That is, what cross-sectional shape we will achieve after making any desired cuts, because these are very helpful when you study architectural designs in your upcoming years. So try to see around the nature and perform these vertical and horizontal cuts on any items, and just visualize that what will be the cross-sectional figure attained after performing both these cuts. So this is all we have in this exercise that completes your question number first.